Alrighty, I was planning on making this later, but I have a bunch of homework I need to do, so I was gonna get this out of the way first. This is gonna be a video showing how to use GDB and Ghidra to reverse engineer Smash on the Switch, since Ryujinx and Yuzu don't support a GDB stub protocol. So step 0 is that you need to have GDB installed. GDB, I use multi-arc, but you could also use the one from DevKit Pro. Right. And the GDB file that I use, also with that, which you can get from my research setup on GitHub, here, made by the Blue Jay. And if you don't have GDB installed, you can also always follow Jam's GDB cheat sheet tutorial, which is really good. After you have that, you also need Ghidra, which I'll put a link to in the description. Well, you just need to install JDK and Ghidra and just run it. Once you have Ghidra up and running, you want to go ahead and make a new project. Make a non-shared project. Pick a location and name it whatever you want. After that, go ahead and click Project, View Repository. Enter ghidra.acropolis.com for the server name and 13100 for the phone number. Hit the refresh button and let it connect. Go ahead and request anonymous access and hit OK. Click OK. And then pick Smush Load Arena and select the repository. Now what you want to do is select the latest version, which is main 1301, and then types and Smash types, then drag them over to your active project here. Now this is going to go ahead and create a local copy on your computer, because it's getting it from a server. Since the server sometimes goes down and you don't have right access to it, so it's pretty slow for me, not gonna lie. So let me go ahead and cancel this because I already did it and I'm on the to 20 minutes. I'm gonna close the project and then reopen the one I already copied over. Once you have it transferred over, go ahead and just double click main 1301. It's gonna go ahead and open it up. Move this to the side and alright, so now this is basically the Smash's binary stuff. You can go ahead and look around. There's labels, if anything looks interesting, or the classes that are documented, or whatever. Namespaces, blah blah. So what you're interested in right now is the functions. What we want to do right now is to see if we can find, when the player is selected, their UI chara hash, or Kara hash, I don't know how to pronounce that, chara. UI chara hash and the color that they selected. What we want to do is go ahead and, well, normally you track it down using either GDB or whatever, but that function is already documented and you can find it by just searching for it here. Or normally you just look through and see if you can find it. Update selected fighter. So this function is the one responsible for setting the selected fighter. Let's go ahead and try hooking this with GDB. If you have the GDB net set up, it'll automatically run. Let's go ahead and run Smash. Alright, so now that Smash is running, let me go ahead and break at, because that's one of the functions supplied here with the GDB net. Then we give it the offset of the function, so let's go ahead and see here. This is 71033107060. Go back there and paste it. Yep. Let's continue. So now whenever this function runs, the game will pause and you could execute your stuff here. For my testing, this one breaks at the start where it sets the character to the demo, so we could test it out when that happens. Something you need to know about is registers. So you see how there's parameters here? Param1, new integer ID, player ID, and player info, new selection info. Those are actually in registers when this function gets called. So param1 is register x0. Param2, the player ID, is w1. And then param3 is x2, which is param3, I guess. And then the numbers after it, where it says the colon and the number, that's the length. So this is 8 bytes, this is 4 bytes, and this is 8 bytes. This is going to be important for when you write Rust code for hooking it. So or for any hooking stuff. If you want them to match up, at least from my experience. Alright, so the game is not doing anything right now, so let's go ahead and... Oh wait, I forgot. They have awkward polls running. You could hold L when you boot up the game to prevent Skyline from running, which means that you'll be working with the vanilla environment. But if you have plugins running and other stuff, you can also still use GDB with that. Just that some stuff might be whacked. So for example, you try to break out a function that's already hooked by Skyline. Okay, this is gonna take a while because I added like 16 costumes for Sonic. So while we wait, okay, yeah, this is actually taking longer than I expect. Let me see if I have a logger running somewhere actually. Do I not have a logger running? Yeah, I don't think I do. Oh. Go ahead and cargo Skyline this and see what's going on. Nothing. Okay, that's weird. Let's go ahead and close the software, see what happens. Oh god, okay. So this is one of the situations where GDB sometimes just messes it up and it's stuck on closing software forever. So I'm gonna go ahead and reboot my Twitch back to our stream. Oh wait, never mind. Okay, never mind, thank god. Reply failure. Thank god for that, oh my god. But sometimes GDB would freeze up your console at that menu and you'd have to force close your switch. Alright, let's quit. And okay, let's run. Oh boy, I don't know what's wrong with me right now. Okay, I have no idea what's going on here. Okay, I just need to restart my dead environment. Switch GDB. Switch GDB right now, just the alias I have for clearing the screen and running GDB with the Alright, so now let's go ahead and try booting up the game again. Alright, so now that we booted up again, we're gonna go ahead and take this. Break at. Oopsie, sometimes it copies a lot of stuff, so you just want to go back and make sure you copy only the offset. We continue. This time I held L, so Skyline shouldn't be there. Okay, but while this is booting up and everything, let's go ahead and look at the function itself. So here we have the new selection info. And as we can see here in the iBar 5, actually, pull that up because, yeah, okay. As you can see here, iBar 5, we're going to go to parameter cache, database, character. Look at the character database. And then over here, it's selecting the new selection info, then the field 0x18, which means it's going to this offset. So as you can see here, new selection info gets passed as a pointer. So a pointer plus whatever offset here is, 0x18, means that, kind of hard to explain. Basically this is the address, and then you're adding 18 to it, dereferencing it, and then that's the value. I'll show you here right now. Where's the magnifier settings actually? Okay. So now that we hit the breakpoint, we're at this place. So if we get PC 3310 and if we go back here 3310 as we said here, we have three registers: X0, W1, X2. Let's try printing the player ID real quick. So print $W1, and here we get 0, which is to be expected because it starts setting characters. It starts from the first player, second player, third player, fourth player, and since this is for the demo area. Now that we have it on 0, let's go ahead and try matching with the new selection info. So as you can see in the function signature, that's the second register, X2. Let's go ahead and just print out X2. Let's just print it normally, X2. As you can see here, it looks like a random bunch of numbers with no relation, but if you print it out in hexadecimal format, this one is basically a pointer right now. So this is the address to this struct. And then let's scroll down here. As you can see here, ivar5 is the character database, and then some random fields from the new selection info. So this one, let's go ahead and see what value is being passed in. So we're gonna go ahead and print. Let me just flip this a bit. A few more. Okay. The new selection info address, which is gonna be x2, and then plus 0x18, because that's the field it's going at. Plus 0x18. And since this is getting dereferenced over here, means that print this out normally right now, we just get an address. And if we actually hover over here, let me see real quick. I'm not sure. Oh wait, yeah, okay. Let's go ahead and print this out as an unsigned long, which is basically a U64 for 8 bytes. And here we have this long hash over here, right? So what we can tell from this hash is basically you have to guess. I guess that's the best I can say. You can look over here where it does some stuff with the local variable. I'm not sure though. But for now, this one, it brings you back this weird hash. Not hash, it brings you back this weird number. So what I normally do is if something looks like this, I just grab like the lower half, go to my hash lookup, and see if I can find anything. If I can't, then I just grab a bit more or a bit less and just keep repeating. And then if I get lucky, I have that. Sometimes I just grab randomly. But yeah, so here we can see that these lower bytes is the UI chara hash. So what we can do is byte shift it to get that specific byte. So if I remember correctly, it was 0x. Oh wait, my bad. You have to. Okay. Yeah, okay, so it was this much Fs. So if we do this, the hash, we get the UI chara hash. And if we continue, and then try to print this again, we get the same exact hash. Oh wait, we do, because here's what I forgot to mention. So after we get this, we're supposed to byte shift it so it's not the same. Then we get the next character. Let's go ahead and run it again. The next character would be Daisy. One more time. And the rest of it I think would just be nothing, because yeah, the demo only has 4 characters. Anyways, yeah, so that's how we get the hash, the UI chara hash. So now let's just disable one, continue, and let the game run. Alright, I'm gonna load the volume a bit. Just probably load from here and then. Alright. So now let's go ahead and just go to the random stage. Let's go ahead and enable our breakpoint again. And let's go ahead and pick a character. So let's say I want Kirby, right? So here we hit the breakpoint again, which means this function runs again. Let's go ahead and see if we get Kirby as we expect, because this is what I click on. And we do get Kirby indeed. So now what we want to do is see if you can find the color, because the color does change. So what we can do is go ahead and from what I can tell, I'm not sure if this actually has it. Oh boy, let me check my notes real quick. Yeah, so over here we can see that it's getting field 0x20. And 0x20 looks like a byte, which if I recall correctly, yeah, that's what it was from byte 1 stuff. Let's go ahead and try printing 0x20. Because it's using it and it looks interesting. So let's go ahead and go here. From the byte shift. 0x20, and we're going to change the unsigned long to an unsigned int. Or unsigned short, my bad. And we get 0. So we'll go ahead and run it, and then try changing the color. Go ahead and print that, and we get 1. Change the color one more time. Print, we get 2. And then, alright, so we got that working. Now we can go ahead and basically implement what we just did in GDB to Rust. So to do that first, we'll go ahead and Oh, forgot to mention, that's everything we have. Okay, these current goals, we don't need them anymore because I already mixed up the order I was gonna go stuff in. So let's go ahead and convert what we just did in GDB to Rust. GDB project, GDB Rust. Go to wherever you have your Rust directory at. Cargo, Skyline, New, and then name your project whatever you want. You want to name it Redirection, or whatever you want. Direction. Or PSS slot redirection, alright. And now you can go ahead, code that, open it up. Then here we have our code. Let's go ahead and open up doors. We're gonna go ahead and import some stuff we're gonna use. So Skyline, install hook because we're gonna install our stuff at a function, which was the function we found. Not found, the function that somebody else found that we were using to update classifier. And then what else? Install hook. And then we need the hook macro itself. Okay, let's change. Yeah, okay, let's keep it actually as install hook. And then let's also import. We'll import the other stuff actually after we deal with this first. So let's go ahead and implement the stuff that we just did in GDB. So first, what we want to do is go ahead and just write the hook macro out. Hook offset equals 0x. Then we're gonna go back here to get the offset. I'm gonna copy where you broke at. And then boom. And then we're just gonna go ahead, public unsafe. We're gonna type unsafe by the way because you're gonna be doing pointer manipulation just like we did here. And dereferencing also copy. The public unsafe function, and then we can call it update selected fighter, which is in GDB. Then we have 3 parameters, remember? Let's bring this over here actually. Okay, so our first parameter, parameter 1, has a length of 8. So we're gonna go ahead and do param 1 U64, because U64 is 8 bytes in length roughly. And then our second parameter, player ID, has a length of 4, so we're gonna go U32, because that's 4 bytes long. And then our third player, our third struct, or our third parameter, the new selection info is gonna be a U64, because that is a pointer, so we don't need to get the struct directly here. And if you want to, you could use a plus default pointer, stuff like this, but I'm not used to that completely yet, so I just use normal U64 and do the pointer manipulation myself. So now that we have these 3, we can go ahead and start implementing our logic. Before that, we want to go ahead and do the call original function, which is going to do whatever the game normally does. We want to change our stuff before we call the original. So now let's go ahead and start getting the UI char ID stuff. So to get the UI char hash, we'll go ahead and just make a new function. Not function, new variable. And what we're going to do first is, remember what we did here to get the character hash, which was doing all this. Instead of x2, we're going to go ahead and do the new selection info plus the offset dereferenced as a U64 and then by shift. So this one will let us get the character hash with the actual original. Let me go ahead and pause that real quick. Alright. This is giving us an error because type U64 cannot be dereferenced. Okay, my bad. So after we do the calculation here, we want to go ahead and cast this as a pointer. So as const U64. So this becomes a pointer, and then we dereference that pointer. And then we don't need the as over here. So now we have the hash. And then let's get the color. So let's let UI or colors or color num, I don't know. Selected color. Okay. Then we're gonna do the same exact thing, but instead of a U64, we're gonna do a U8 because the max is 255 and 0x18 with 0x20. You can see here we found it through 0x20. And now let's go ahead and just, for testing purposes, we're gonna go ahead and just print them. So hash Color hashtag. That's color hashtag. Yeah. And fortune will call it. For the color, we're gonna go ahead and color. And you just do UI chara hash here and color. And now you just go ahead and install the hook. Let me go ahead and install the update so better hook. Okay. And that's basically it for our function right now. So we have the selected spider and we have the selected color. Let's go ahead and cargo skyline run. While that does that, let's go ahead and make look files real quick. Clean up some stuff. The breed actually is, so I'm gonna kick that out real quick so it conflicts with it. And I think that's all I need to get rid of. Alright, so now we just let it compile. Ensuring directory exists, transferring file. Alright, now that I did that, we can just go ahead and click our debugging session. Close the game. Run the game. And now we just have the game running. Just wait for the game. Alright, we have the logger. It's just gonna go through my other plugin stuff. Hopefully it doesn't take too long adding the folders for Sonic. Alright, so as you can see here, we have some hashes set. Go ahead and see if we can find anything. Brave, Pikachu, let's see, Ina, and Falcon. Alright, let's go ahead and just run in game and see if it changes the color too. Alright, so let's pick GDB for example, and the color's changing. Alright, so now that we have our color changing stuff and the hat for the character, let's go ahead and set the color so based on the hash. So for example, let's say, well, before that, let me go ahead and explain how we're gonna do the new CSS stuff. So let me go ahead and open up an editor. Where's PRC? Go ahead, open up sample chara DB I have. So here, when the game goes ahead and loads the fighter, so where's Sonic? Sonic here. It'll check the UI chara ID, and then it'll load the fighter kind for that fighter that's set. So I have over here UI chara Sonic, and for my new entry here, I have type G Sonic. You could check based on the UI chara ID. So let's say, for example, if UI chara hash is equal to my type G Sonic, entry, alright. Then we can go ahead and edit the selected color. But here's the thing I forgot to mention. This is a pointer, right? So the issue here is that this dereferences it, which makes this separate. Not what you, so if you edit this and then pass back in the new selection info, the color won't change. So what you want to do is actually remove this and change that as a constant pointer to as a mutable pointer. So now you want to dereference it on each instance you want to at least see it or change it. So if you want to change it right now, we just go ahead and do this. Set the colors whatever you want. So if it's fighter type G Sonic, we can go ahead and take whatever the selected color is and increment it by the index you want to start at. So let me just write out real quick here. So let's say I have normal Sonic, right? Normal Sonic is at C00 to C07, right? And then my Type G Sonic is at C08 to C15, right? So now, when they pick UI Chara Type G Sonic, right? The game will get. So for example, they pick the first lot. It gets color 0, right? So UI Chara Type G Sonic. And then it tries to load normal Sonic, right? Loads fighter kind Sonic. That's color 0, as expected, right? So that's why even if you duplicate the struct, give it a new UI Chara and whatever, it'll still start at the selected number, color 0. So what we want to do is set a custom start index for UI Chara Type G Sonic. So a custom start index means, let's say, UI Chara Type G Sonic start index is equal to, say, 16, or right? Oh, my bad, not 16, I meant 8. Because from C00 to C07, that's normal Sonic. C08 to C015, so the start index will be the costume flag here. So now, we go ahead and pick, whatchamacallit, UI Chara Type G Sonic, color 0 again. 0. Game sees color 0, right? Plugin intercepts it. Checks UI Chara Type G Sonic's hash. Checks to see if UI Chara Type G Sonic. If it is, and take the color and add the start index for it. So now they pick, then return the result. So now if we pick 0, from that line, if we pick 0, Type G select 0, it sees that it's 0, so it's going to take, it sees that it's Type G Sonic, so it's going to take 0 plus the start index, which is 8, which then becomes 8. So now it sets the color to be 8 behind the scenes. And then it just basically does that for all the others. So if we have 1, if we select 1 on Type G, then it's plus 8, and then we get color 9. That's basically how the logic should walk through. So now we just go ahead and hard code it for now. I'm gonna hard code it because, well, more specifically for when you're writing proof of concepts like this, it's already hard code stuff. But once you move on, then I would recommend hard coding. But you want to also add another failsafe. So if selected color is greater than, if it's not greater than, if it's less than the start index, then you want to increment it, just in case. So now we can go ahead and run our custom stuff. So let's go ahead and run this. By the way, this, I'm not going to go over how to add the stuff to the character database and adding the costume slots, because that's going to take forever, but we'll see. I just realized I held down. But basically what you want to do is to add a new character slot, you're just going to go to your character that you want. For example, on the Sonic, I put Sonic, Control D on PRC editor, scroll down, you have your duplicated struct. Edit what you want to edit, the name ID, and the character. That's like the most important ones. And I guess the variation character and how much colors you want. And whatever else, if you want to change the series or whatever, I don't know, I don't care. After you edit that, you go ahead and save it. Don't forget to edit the layout db.prc. And then, that's it, I think. You're good to go. You can also make them echoes like how I did here. But for now, let's go ahead and test it out. Alright. So, let's go ahead and see if Type G Sonic has over here. It's gonna take a while to load, but the UI takes a while to load, but let's go straight over here first. Okay. So now let's say we pick normal Sonic. We get color 2. Color 4. We get color 8 if we pick Type G Sonic. Let's see why. Color 11. And then let's go back here and pick a normal Sonic. So you see how we have another Sonic entry, but it goes back to 0. That's because we don't have a threat index check here for this one. But that's basically it, honestly. So for example, so let's go ahead and add this Sonic. And then let's go ahead and add a Sonic that does have a check. And let's go ahead and add a Sonic that doesn't have a check. So
Sonic.
We have 3 Sonics right now. This one is default. This one we implemented our custom special check for, which increased the index. And this one is also another entry, but we don't have a check for it. So let's go ahead and run it. See what happens. We have color 0, color 10, color 3.
3, 2.
And then boom.
Begin testing.
No idea why Type G... Oh wait, yeah. Okay, so... I should let it just go. The reason why Type G Sonic's UI doesn't load is because the function for loading the UI stuff is separate from this update selected fighter. My previous videos had that function implemented because I found it before when I was helping somebody else with this stuff. But whatchamacallit? Let me just continue. But yeah, that's a separate issue they'll have to figure out. And that's about it. So yeah, from here you could expand upon it by going ahead and, well, making probably a static mutable. Well, what I did was making a static mutable hash map, inserted the character hashes and the starting index for them. Then, what else? Then yeah, then added the checks, fixed this up so it's dynamic. Added the UI fixing stuff, and what else? Yeah. But yeah, basically, fix the UI. And then if you want to go even more fancy, you could go ahead and add the new thing, add a new entry here, a new key to the struct, called start index or whatever, and then parse it from here instead of having to do another file or whatever. I don't know, it's up to you and how you plan on attacking it. Probably just gonna release something like this later or something. It depends. I don't know, it depends on random stuff. I don't know. I got other stuff to worry about right now. That's about it. Time to go for me to go do my homework and you guys do whatever you want, I guess. I don't know. Bye bye.